Natural logs are better for your health. How about that? Okay. We studied common logs, right? You already identified that a common log is base 10. Correct? Okay. Natural log is the other one that comes up, and that's why there's a key on your calculator for it. And it is denoted, okay, we don't write it like that, but that's what it is. It's base E. Okay? We write it like this. Right? So that's why the calculator has that LN button on it. That's what we use it for. Okay? So if you see that notation, it means log base E. Right? All right, see the key right there. That's your natural log key. Yep. And then if you notice the blue, the second key is e to the x. Those inverses hang out together, right? On log, common log, 10 to the x, they hang out together. So you're very logically laid out here to do inverses of logs and exponents. Okay. So what is the value of that ln e, natural log e? 1. Yeah, 1. Right. Do you understand why?
Yes. That's log.
Because this is a log base E, E. What exponent of E makes E? 1, right? Okay. What about this? Yeah, 2. About that. How about this? Okay. If you use your properties of logs, what can I do with these two items? They're multiplied, so I can split and add, right? Which is ln2 plus 1. Do you know what ln2 is? It's a number. 0.69 what?
3, 1, 4, 7.
Okay, and you can finish it from there, right? Okay. So a few things that you want to know. Natural log E is 1. Here's the other big one that we use. Oh. Natural log at 1. What's the x-intercept of a logarithmic graph?
0.
No. The x-intercept is 1, right? So at natural log at 1 is the value of 0. That will come up all the time working with natural logs. Okay? You'll be all right.
Yeah. Sorry. Oh my goodness.
Okay, so general log information there on natural logs. Let's take that and change it to natural log. So use the change of base formula. What are you going to have? Okay, we know it's going to be, which one's on top? Yeah. Okay, so if you need to change the base, you can to natural log. You could use log base 10. This is really a personal preference thing here. You can use log base 10 as well. Both keys are on your calculator. Okay.
That's going to be LM.
So just be careful that you close the parentheses in your calculator if you calculate that number. All right. It just so happens that this is 3.090. Okay, here's the meat and potatoes, because we like meat and potatoes, well, most of us. Okay, we will solve a lot of equations with natural logs in them in the next year plus. Can we solve that for x? First step? Yeah. The negative, in fact. The idea here is to isolate the log. Okay.
What's the other? Can we actually move 16.25 to make it the exponent of log?
You could.
You can, I don't know.
Yeah, you could if you want.
So if you want to move it up, do you keep it negative? You know, or is it just the positive? Is it going to be the log?
You can move the negative over here, or you could leave it with the exponent.
Okay.
Okay, what is that number? Negative 0.4. How do I solve that problem? Your book will put anti-log negative 0.4. I hate that notation. I've told you that. So what is that? What's the inverse of natural log? E to the x, right?
Yes.
So we need to use the inverse of natural log. Okay, these two will cancel, right? If you want a running commentary. So what's e to the negative 0.4?
67032.
Okay. I think it's a much better way to think through these instead of anti-log. It sounds so negative, anti. Okay, so basic natural log solution. Good? Okay, your book example has this in it. Your book solves that with the natural log. Your book does this.
Is that wrong?
No, it's a perfectly viable option.
there an easier way to do it?
There was an easier way to do it. What did I coach you to do with that problem already? What log base would you use? Okay, 3 is a perfectly viable option. So
That's gonna be.
right? What does this do with this log here?
Move down.
Goes bye-bye, right?
Oh.
So now you only have 1 log to deal with. Over here you're going to have 2 of them. Okay, so we have 1 decimal here, and over there we have 2. This is just easier to deal with. Okay, so don't take your book's advice. Use the bases that you're given and inverses of the exponential or of the logs. Okay. Do you want me to finish this? Okay, what is that value?
Log 7 or log 3.
That would work.
That's gonna be 1.77.
I couldn't hear you.
1.77.
Give me more.
124. 124.
Okay. Again, working these problems, go out lots of decimals because you don't want an error at the end because of a wrong estimate, okay? Like you could do a whole bunch of stuff here. What do you want to do? Okay, that works. The hippity, hoppity, poppity, boom. Okay. Now it's a simple linear equation. Well, it was before too, I guess. Solve and divide, right? Or subtract and divide? Let's subtract that. What'd you get? 0.022.
222866.
X. And then divide.
Negative
7.742. Truncate around, I don't care. Take your pick. Okay, do you want me to show you an equation solved on the calculator? Okay, let's do that. Where did I go? Okay, where is that true? 6 to the x squared minus 2 equals 48. Okay, that's a 2. Well, if I did, then I'm sorry. Where do I put those? We've solved these on a calculator before. Equations. How would I solve that equation?
Yes.
Yes, you solve equations with math. Thank you very much. Not the math menu.
You can use log 6.
Oh, wow.
I'm gonna.
Fancy that.
But would these be easier?
Here's how we're gonna. Do
Remember the thing I told you.
you remember how to graphically solve these in the calculator?
Absolutely.
Okay, Kellen, tell me.
I lied. Don't you move 48 over, make it equal to...
I know, but this is way shorter.
No?
That's what he said, though.
Hey, I trust you. Did you draw it?
Okay, there's one side, right?
Shorter. You don't have to put it in cut it.
Kellen, I could put minus 48. What would my second equation be? 0. But I'm not going to worry about that. I'm going to put 48 as another. All right, so one equation, other equation. Right? This is starting to ring a bell. How are we going to find the answer to that value of x? Yeah, that's it. You calculate the intersection. So graph them. Let's hope that definitely not going to show up because my window. What do I need to set my window at?
21.
That's the y values, children. Right, okay. I heard some of you say it. So I'm going to go from 45 to 50. Because William Wallace killed 50 men. Good. If you guys have never seen Braveheart, I'm very disappointed.
Yeah, great part is great.
Okay, there are your intersections. How do I calculate intersections? Calculate, intersect, first curve, second curve, and then put your cursor where you think the answer is. 2.039. Right, Brandon? Yeah, put shut up. Pay attention, like a good boy.
The exact thing.
And what's the other one going to be?
This one is what I understand from.
Negative 2.0.
There you go. Why are there two answers?
That's why I wanted it that way.
How you call it?
Square.
Yeah.
This next square.
X squared.
You
Okay.
can solve it algebraically too, right?
Any questions on those?
Yes.
Come on, man.
What is it, Caleb?
I just want to know what I'm doing wrong with my calculator.
I don't know.
User error.
To be honest with you. Okay. So I'll come look in a sec.
They're gonna look it up. I just, it's gonna be 90% lost in the
What?
I'm sure one or two got it.
All pretend that we're back in the 7th grade.
There you go.